All right. So, what's that? Oh, yeah. All right. Tell him. Okay. So everybody, listen carefully here for the next steps. We are now going to break into groups. So if you are on the right side of the room, my right, your left, this side, you are going to go outside and get on the bus. And the bus is going to take you over to Afri-Set, to Professor Hughes's lab. And you'll be doing a couple activities over there. You'll be meeting with the AirQuo representative, so Usman, you should go with them as well. And you'll also be doing an Afri-Set tour. Everybody on this side of the room, my left, your right, you stay here, and you'll be doing a sensor demonstration led by Teddy, who is getting set up there in the back. All right? So if you're in the middle here, then go to whichever side you're closer to. All right? And yeah, you can, if you want to leave your bags here, that's fine, because there'll be people in the room the whole time. Any questions about the plan? Yeah. You get to do it on Wednesday. You'll get it on Wednesday, so you'll be flipping on Wednesday. Yeah, so if you're in Group A, then you'll be doing the other activity on Wednesday, all right? Okay. Okay, we're going to go ahead and get started. Is everybody ready? So much like with Steve's group activity, we're going to also get into groups. So the same way, if you just turn around and partner with your table behind you and form small groups of 6 people-ish, something like that. And if we get Teddy's slides going. Okay, that group's ready.
Good afternoon. Thank you. I'm Teddy from Kenyatta University. So I'll be conducting hands-on on Arduino. So I will have to restructure where you're seated so that we can draw near, because we have some 2 groups which are even behind the cameras. Please kindly draw near. We have enough tables, kindly, if you don't mind. Yep. Any. I can be just. Yeah, you can use these chairs. Yeah, you're okay. You're okay. You're good. I need power supply. Where? Yeah. Yes. Yes, you can just open your kits. Yes. During the demo. So you'll show them the power cable, which is which powers and programs they're doing. No. Oh. Oh. Do you have some power? I want you to roll up the display. Then I want you to run the slides. I'm waiting for the slides so that we can start. You can open all the groups. You'll find a certain cable, micro and a USB cable. You can just open it up. Okay. Thank you. So I can have your attention, and then we can start with the slides, and then we can go on with the toolkits which I've provided for each group. So my name is Teddy Mwendo Mutisia. I'm working for Kenyatta University. We have a data center for Kenyatta Columbia University Data Center. And we started this collaboration 3 years ago, collecting data for PM2.5, ozone data, and we have a number of local sensors, purple layer. We have 2 purple layer. We have 2 ramps. We have 2 grid reference monitors. We have TIOM. We have ozone reference grid monitor. We have a NOx, which we've been using for the last 3 years. So I'm going to do a slide presentation of hands-on on Arduino. Next slide, please. So, Arduino is a motherboard, which is it's a PCB board, which is more of a small computer. You have it. It's a blue one. It's called a D1. You can still use the D1. It's an open source software. You can go back, please. Arduino is an open software, a PCB board whereby you can restructure to your suitability. It has options. It has an analog in. It has an analog out. You can write data. You can send data to Arduino. By the end of the day, you'll be able to create different kind of sensors with Arduino. What we have in your kits It's a D1R1 ESP8266, which is an advanced Arduino than what we've been using in the local markets. What it does, you have to create a Java code using IDE. Using IDE. What it does, you can, with the advanced ESP8266, you can provide a scoop of emails which can be provided that data that you make. I do have a small sensor which has a display of PM2.5, which is closed here. I made it with a different version of Arduino, an older version, but they are changing the version to an upgrade version because I cannot send data with the current Arduino that I have used, but you can store data through an SD module card. So we'll go and check on the slides and we'll see what we can have. Next slide, please. Also. So we have some types of Arduino boards. We have Arduino Uno, we have Arduino Nano, we have Arduino Leonard, we have Arduino Micro, Arduino Nano Every, we have Arduino Nano 33 BLE, we have Arduino Nano 33 BLE Sense, and we have Arduino MKR0. All these Arduino boards, all of them, they are different from each other. They are an upgrade from one to another. You can, I'm sure most of the data providers who are here, they do have a ramp 110, you have a purple layer, and you have an LCD screen. You can use a TV, maybe. And through the boards, we have provisions for HDMI. So depending on the code that you write, you tell the code, what do you want me to do? I want to take data from purple layer every 30 days, display on the screen, analyze the data, and send the data in my email and leave the display on the TV. If the TV is a distant, away from the low-cost sensor, you can find this version that we have, which has a provision of SSID, the provision of Wi-Fi and password, and you can do a key input of all that at your own suitability. You can do 4 emails, you can do 5 emails, you can connect 4 screens, both of them, all of them, to provide even different data from the same purple layer. And if you want to change the provisions of the data which is provided in the screen, you can change into graphs. Depending on the Java code that you're going to write, you should be using IDE. If you have your laptop, you can check IDE program. I'm going to do a display on it, on how to use it.